Hi, today we're going to talk about integer rules, what it takes to add, subtract, multiply, and divide integers. First, we need to understand that integers are just positive and negative numbers. As you look at 0 on a number line and move to the right, notice that numbers tend to get larger. From 0, as you move left, though, those integers, even though their absolute value is larger, those numbers actually get smaller and smaller the farther left that you move. One thing that you need to understand in algebra is that there is always one set of rules for addition and subtraction, and a different set of rules for multiplication and division. This is true even with fractions. Remember, with fractions, for addition and subtraction, you have to have a common denominator. However, with multiplication and division, you do not need a common denominator, and you just multiply the top numbers together and the bottom numbers together. So the same is true with integers in that they have their own rules. The first rule for integers is that we're going to take the same signs and we are going to add, hold on, let me turn my pen on. We are going to same signs, add, and keep. Okay, and really what we're keeping is the sign of the number. Let's look at a couple examples of this. First, I'm going to show you these examples with the algebra tiles. If we take 3 and increase it by 5, do 3 plus 5, notice that both those numbers are positive. Okay? The plus sign in the middle actually makes the 5 a positive 5. So when we take our 3 positives and our 5 positives, since they're all the same, we add them together and we get a total of 8. Okay. In this next problem, we have negative 2 plus negative 4. Well, negative 2 is represented by the 2 white algebra tiles, and negative 4 is represented by the 4 white negative 1 algebra tiles. So what we have here are 6 negative 1 algebra tiles. So when we add the 2 that have same negative signs, it's going to equal negative 6. Now this one is a little tricky. Here we have negative 3, which is the 3 white algebra tiles. And then we have minus 2. And the reason that minus 2 gets white algebra tiles is because of the minus sign. Excuse the announcement. The minus sign actually functions and makes the 2 a negative. Okay, the sign before a number is always the sign that it takes. So since both of those are negative, our final answer here is negative 5. So now we know our same sign rules, okay? Not all problems have same signs though, so we're going to talk about different signs. And when we have different signs, what we do is we subtract the 2 numbers. Okay. Not only do we have to subtract though, we have to take the sign of the bigger number. And if you like little songs that help you remember the rules, you could kind of sing this little song to the tune of Row, Row, Row Your Boat. Okay, so for instance, if we had, let's say, negative 9 plus 6. These two numbers have different signs in that the 9 is negative and the 6 is positive. So what we're going to do is subtract the 2 numbers. So 9 minus 6 would give us 3. But since the 9 is technically our bigger number, okay, or has the biggest absolute value, we are going to make it a negative 3. We could look at these with algebra tiles as well. Notice in the first column we've got 5 minus 2. Now the 5 are red because they're positive. However, the 2, okay, because of that minus sign, that 2 is negative. So whenever we have a positive and negative pair, what we can do is they make what's called a zero pair, and they cancel each other out. So think about those canceling each other out, and that helps you understand why our final answer is 3. Okay, again, all we did is subtract these two numbers and take the sign of the 5 because the 5 is the larger number. Same thing with negative 3 plus 8. Here we've got 3 sets of zero pairs that cancel out, and we have 5 left. Okay, so that means our final answer is 5. And negative 3 plus 8, we subtract, we get 5, and then we take the sign of the 8, which is positive, and that's a sign of our answer, positive 5. Now with 2 minus 6, we also have 2 sets of zero pairs that cancel each other out, leaving us with negative 4, or 4 negative 1 algebra tiles. If we subtract 6 minus 2, that gives us 4, but since the 6 is our bigger number, the negative sign belongs in our answer. So now that we've learned most of the rules for addition and subtraction, there's one more rule that we need to learn, and that's when we have neighbor signs. And neighbor signs are just two signs that are right next to each other. And we see this most in problems like 3 minus negative 4, where we have those two minus negatives side by side, and those two minus negatives are going to change to plus plus. So it's the same problem as 3 plus 4, which is 7. We'll take a look at these next problems that have neighbor signs. Okay, 15 plus negative 2. Okay, again, the neighbor signs are just the two that are next to each other, and really, unless it's a minus negative, there's really nothing more that you need to change. Since these have different signs, we are going to subtract, so 15 minus 2 is 13, and we're going to take the sign of the bigger number. The 15 is our bigger number, so we're going to keep our answer positive. The second problem, however, has 2 minus negatives. Both of these are going to change to plus positive, and you can think of the minus negatives as a broken plus sign. Okay, and the two pieces come together to make a plus. So negative 9 plus 4, that is now different signs. So different signs we subtract. 9 minus 4 is 5. We take the sign of the bigger number. Since the 9 is bigger, we're going to keep our answer as 5. Same thing with 22 minus negative 6. We fix our broken plus sign and make it plus plus. The two negatives make plus plus. So 22 plus 6 is 28. Now let's talk about the rule for multiplication and division. Remember, this is a completely separate rule from addition and subtraction. When we multiply and divide integers, positive and negative numbers, we can make this tic-tac-toe board kind of where the pluses went at the diagonal. Notice what this means is a positive times a negative equals a negative. A negative times a positive equals a negative, and a negative times a negative equals a positive. So this simple chart will help you remember your positive and negative rules. So if we take a look at the first example, 15 times negative 2 is going to be negative 30 because it's a positive times a negative. Negative 9 times negative 4 is 2 negatives, so that's going to be a positive 36. 24 divided by negative 6, that's a positive and a negative, so that'll be a negative 4. Negative 35 divided by negative 7, two negatives give us a positive 5. And here we have 4 divided by negative 16, or you could think of it as 4 over negative 16 as a fraction. Okay? And since the bigger number's on bottom, our answer is actually going to be a fraction. So we're going to reduce our fraction by dividing